Hello dear scholars. Today I wanna describe you about one of important concept in statistical uh, softwares and as well as statistical concept. The name of simple moving average. Before I wanna describe this concept, I want you to visit our website with this address and also subscribe to our channel, YouTube channel with this address. Okay. You know, simple moving average has different ways for calculating it, but uh, in this video, I try to describe two of them that popular in between different ways of calculations for SMA. For easy pronunciation, I call it SMA instead of simple moving average. Okay, we have two ways. We want to know about two ways of SMA, and now I want to describe the first one and at the end the last one. Okay, you know, SMA, if we want to know about its concept, the SMA offers a simple way to smooth your data and if to dig deeper into the simple moving average and how it's put to use, we need to view several samples. But if we want to know that how can we use it as an equation or maybe in an Excel file, first of all, it is better to know about the main equation. It should be calculated with this formula like this. And what about this component here? The y refer to your desired or maybe your sample, such as, for example, price of staff or maybe precipitation in meteorological science, precipitation, temperature, this concept, SMA, used in different science. So in our field of study, such as water, maybe meteorology, geography, and like this, it refers to, for example, as a familiar sample. For example, it is temperature. So if we want to use the temperature to get moving average, we want to show you how can we use this equation. Okay, the moving average is calculated as the sum of n observation, as you can see here, and after that divided by n. The n is the number of the observation that you want to get the moving average for that. With a sample, you can get a better what about this, that sample and this equation. Okay, for if we want to better clarification about this concept, moving average are often used to help highlight trends. I mean that it's really similar to get your trends of your data. I mean that when you want to smoothen your data and make a trend line on your data, it's clearly similar such as the moving average activity. Okay, the MAS can be used to identify the direction of the trend. In next slide, I will describe it better for you. And if we want to smooth out volatility and as well fluctuation, or maybe that if you want to remove the fluctuation and variability on your data and make it easier to view the variable trend to get some reports of your data, for example, increasing or maybe decreasing the trends of your data, it is the best way to do moving average on your data. Okay, for the first sample here, we want to know that if we want to calculate SMA for 10 months with that's 5 months interval. In another clarification, we want to get for a series of data the 10 months of fifth interval as an interval. And so, how can we do this? What's going on when we want to apply this formula? For better understanding, in this equation and in this sample, we want to know about the 10th month. So T refers to the 10 months of the data in the series of your data. So we put 10 instead of T. So in the rest of the equation for YT, so we put Y10, 10 instead of T, and plus T minus 1, it means 10 minus 1 should be 9. Add the rest of the equation up to the 5 interval in as a simple moving average. So we want to know it for just 5 components in our series of our data. So it should be like this: y10 up to y6 divide by 5, the number of the interval in the period of interval. Okay, so it should be, for example, if your data refer to precipitation, you should put the precipitation from the 10th, I mean that order, the 10th number of your precipitation in your months, and blah blah blah, make summation, make this summation, and then divided by the interval 5. Okay, if you want to know it better, let's go to a Excel file for better understanding this sample. I prepare an Excel file here, and I want to show that how can we fix this problem here. So it really be easy if you want to know that how do you want to use it. If you know about this sample, you can easily understand how do you want to do that and how can face with this problem. Okay, this station data related to one of these stations in the US, and these data in this column related to temperature in Fahrenheit. Okay, it is started from January up to December for this temperature data. But in this sample, in this example, I want to show you the moving average for this interval, 3 months interval. So when I want to show it how can be started, you should be accurate, be caution about the interval. When we call 3 months, it better you should have started at the third place of your data. 1, 2, 3 from here. March. Okay. For getting the moving average, if I want to calculate it as the formula that I show it to you here, this one. First of all, I can make a summation for the third of the data, and after that divided by 3. Another way is in this Excel file, I write it here, equal average function. Sorry, I could change it. Okay, average, like this function, average, and as well get 3. They take 3 of these series and put the parentheses and press enter. Okay. The first number, the first value in this series for moving average is 35. Okay. If I wanna calculate the others, I can put them all here, and so when I see this sign plus in black color, I can do this activity, take it to see another data for moving average. This is a warning, it is not important, you can ignore it. So these are the data with 3 months interval for this simple moving average. It's really easy for you. Am I right? Okay, I'm sure that is so easy for you. So if I want to show you how can we put it in a graph and better clarification of our result, I wanna make a graph here to better understanding of this data. Okay, I mean that this graph, like this one. Okay, it is a simple graph. If I want to add different activity on it for better visualization, I don't like here I lecture you how can do this. I put another video in our YouTube channel. You can refer and watch it for better understanding how can improve this. In this lesson, I don't want to lecture you how can improve it, the visualization for better presentation. No, that is not my aim in this video. However, for make a trend line on it and moving average, this is the second way here. First one with equation as you done it here, and another give a chart I mean that chart graph here for see what is the trend and moving average on this graph. Okay, after you depicted the graph, you go to this icon, add chart elements. If you click it, you see at this one trend line and track it up to this more trend line options. Okay, wonderful. We can see different options here. We don't want to describe each of them, but this is my intent, moving average. Okay, I click it. I saw here the trend line and the moving average line here. And so, since our internal is 3, so I should change it to 3. Okay, nice. I can see here. Okay, if I want to make it the graph, for example, the color line, maybe like this one, or if you change the white, you can do that, or maybe change the type of the I mean that component show to you. You can change the dash type to like this one, or maybe everything that you want, you can do that. Okay, you know, this is there is another tip here that is good for you to understand. You know, since our interval is 3, so we start from the third cell in this Excel file, the third value in our series number. So in our graph as well, this dash line started from the third month, since our data in moving average started from the third cell. So 35 is the first year, 35 for the March month, and it continue up to the last month in December 15. You can see that in 15 for the last data in moving average. Okay, if I want to show you another example for this equation for the first sample, popular sample in simple moving average, the second sample is here. You know, we have several data from 2010 in monthly format up to 2011 for 2 years in monthly format of temperature in another station in the similar station in US for temperature in Fahrenheit. So in this sample, I want to show you how can we use it with 7 internal for moving average. 7, I mean that months in SMA. Okay, so could you please let me know where is the proper cell? So how can I start this equation in this sample? Yes, you're right. I should have started from here, the seventh cell, maybe July, because 1, 2, 3, 4, excuse me, 1, 2, 3, 4, 5, 6, and the last one is 7 in July. So since my interval is 7, I should have started from after 6 cell in 7th cell. Okay, as the previous example, I put the average equation, average function here, and take these data for the equation and press enter. And I saw here the result. I can put it the mouse here in this corner and take it here to get the result. Okay, this is finished, and these are the results for 7th moving average with 7th, I mean that interval. It's really wonderful and it's not very hard to understand. If you want to put another graph, you can follow these steps that I told you before here. Okay, we want to know about this equation and this function in the second way, and that better understanding. There can be no complete understanding of MA without understanding of trends. These are so similar, match with each other when we say moving average, get a smoothing your data, or maybe get trend line on your data. These are similar. We have three steps in the concept of trend. The first one is an uptrend, means when that the supposed variable is moving higher. The second one refers to the downtrend. It means the supposed variable is moving lower. And the last one is a sideways, not the first, not the second. It is a new one. The supposed variable is moving sideways. Okay, it's not really hard. When you see another example, you can understand it better. Okay. Moving average lines are used to help us more easily identify the direction of the trend. And a smoothing techniques reduce the volatility and as well, that fluctuation your series, and which allows to interpreter, analysts, and the others to identify important economic trends. It's really wonderful for them. And the AMIC technique offers a simple way to smooth your data, and that's not really hard at this step. Okay, as I told you before, we have lots of different equations for calculating SMA, but in this video, I present you the two most popular ways that many researchers do that. Okay, we learned the first one very well, I'm sure, and the second one is this equation. The equation maybe is really at the first view, it's maybe hard to understand, but it's not really hard. You can understand it very well after I describe it to you. In this equation, you see different things. But please, when I describe it to you, imagine on your mind the first equation, the first way. It is a small difference between this way and the first one. In this sample, we have another component here, another parameter with name of M. And in this equation, M refers to the integer of your data as n divided by 2. What is n? N is the number of your variation, your observation, the interval. That. When you want to get, for example, 5, you should put it 5 here and then divide to 2, and after get result, for example, 2.5. Then you should extract the integer number from 2.5. It's gonna be 2. So here the integer, the m value would be 2. Okay, in a sample I describe you it better for you, and don't worry about this equation because I show you another graph and you can understand it very well. Okay, in this example I wanna repeat the previous example in this equation. It should be, we want to calculate the 10th month with 5 months as interval with the second way of SMA. How can we do that? As I told you before, since our interval is 5, so we should put n as 5, like this one. T should be the start of the cell in Excel file, or maybe the start of the month that you want to start for calculating the SMA equation. So T refers to 10 here in this sample. And I should to track this equation with M as 2, because 5 divided 2 should be 2.5. If I want to extract the integer part, it should be 2. So 5 equal to m equal to 5, n equal to 5, m equal to 2, and t equal to 10. I track this one like this. y 10 minus 2, it's gonna be 8. Y 8, like with this in index 8, this one. Another one, y 10 minus 2 would be 8 plus 1 should be 9. Y 9, like this. And blah blah blah. The rest of the formulation, it should not be hard for you. You can understand what am I saying here. Okay. And then divide after the get of the summation, I should divide it by 5 to get the result. It's not really hard. It's really easy, I'm sure. So, for better understanding, I wanna show you an example with a series of data from 1961 up to 1919 for a series of data for head crew T3 data related to the temperature anomaly in degree in centigrade, I mean that. Okay, so what am I said here? You know, this series of data in this line, you can see here. You know, the thin line refers to the observation data, and the thick one, the blue one here, is referred to the moving average. But which the interval? It's for 3-year moving average. Okay, this sample for 3-year moving average. You know, if we want to show you as an example, the smooth value for example, 9055, you can see here. This is the same as, I mean that both is matched with each other. The observation data and as well the trend line data. But if we want to go, I mean that for 2 years after here, or maybe 1 year after, 1956, you can see here that we have a decrease in the value of observation data. But in the trend line, we don't have this decrease trend here. So we filter the variations and as well, I mean that the fluctuations, we remove it in the trend line. A smoothing reduces the variance of the original data, I mean that. So the longer smoothing interval, the greater the reduction, you can see here. If we want to use it for example, a bigger interval, for example, in this sample we saw 3 months for interval, 3 years in interval. If we want to do it for example, 11 in the next picture, you can see that the smoother process is really much more than this. Okay, so another tip that I want to show you is related to the first and the end last of the series. Let me time to see you in the next step, in the next, I mean that sample to you. You know, this sample is related to the 11 year as moving average for the interval. You can see this line that it refers to the, I mean that 11-year moving average is gonna be smoother than the previous one. So if you wanna show you in with each other, I went to the other, yes, this one. A slide. The first one refers to the 3 years interval for moving average, and the second one is for 11 years as moving average. Okay, but we want to understand to another tip, as I told you before, for these points. What are they? Why am I highlighted them here for you? Let me take a time to go to the equation. I want to show you another tip. Okay, let's go to see the equation in this slide. Okay, I'm sure that you remember this component in the second way of SMA calculation, M. You know, the variable M, as you remember, it refers to the integer from the result of n divided by 2. Okay, Be careful. In the second way of SMA, for getting the interval, the n should be an odd number. It's really important in the second way. But in the first way, it is not important. It should be no. Maybe it can be odd or maybe even. But in the second way, n should be an odd number. Okay, for n, you know, the points that I showed to you in the previous slide refer to this value m, So when we get this result for m, this value, this amount shouldn't be included in the trend line, in the moving average trend line. Okay, so get in your mind this value. So please let's go to this slide. Okay, so now you can better understand what am I saying about these points. It is m. So for the first, and the first from the first start of your trend line, for your moving average line, and for the rest of the data of your, I mean that the second samples in 11 years, we have these points refers to the n value. For better clarification, review it again. In this sample, the interval is 3 years. Okay, so m should be the integer of the result of n divided 2. Okay, do you remember? Okay, so 3 divided 2 would be 1.5. If we extract the integer part, it should be 1. So the first value from the trend line, from the moving average line, and the last value in the observation data does not include it in the trend line of your moving average. For the 11 years as interval moving average, okay, it is 11. So for getting the number of n, 11 divided 2, it's 5.5. When we extract the integer value, it's gonna be 5. So 1, 2, 3, 4, 5. Fifths of the number in your observation data and the last fifth of your data in the observation series doesn't include in the trend line for the, moving average line. Okay, by the way, this is so important that you fix in your mind that why they are not in the including in the trend line. Smoothing reduces the variances of the original data, as you can see here. We are reduce smoothing reduces the variances and fluctuation, as you can see in 3 years. When we get it longer, from 3 to 11, you can see it is very intense. I mean that the fluctuation, the peaks value is removed here, as you can see, and it is so much more smoother than this value. So be careful when you want to get a 3 for interval or maybe 11 for getting your interval. However, I mean that the real data are fluctuating much more, and the smooth line deviates markedly from the original data in your time series. This is really the most serious point in your consequence of smoothing. I mean that when you want to smoothing your data with moving average, you get a smoothing or filtering, and the moving average shifts the peak value of your main and raw data, observation data, so you can maybe see different shifts like this. For example, This we see that here in this sample, the temperature is decreased here in 1915, but here in trend line we can't see the decrease value in this red line. As well, in this chart we can see different that variation in this observation data, but now a smooth with an 11-year smoothing interval. This illustrates that how more and more details are lost as the length of the smoothing is increased. When the interval smoothing increased from 3 to 11, we lost lots of different information from the observation data. It is really important for you. Okay, I think now you can really understand the means of a smooth, simple moving average and trend lines, and the variation changes in your trend lines data after getting moving average. And if you have further question, you can go to this address and put your questions, or maybe if you want to tell us your feedback, you can go there and let us know for your feedback. As well, please subscribe to our YouTube channel with this address. You can watch our new videos and software tools, different production that we try as a research team in Agrimasoft to develop different concepts which you have in videos or maybe in tools. If you need another maybe tools in your science or in your field of study, you can order via the Agrimasoft website or channel in YouTube. You can like and share our Agrimasoft videos like this. Okay, by the way, I think everything is now finished, and I hope this video is helpful for you and you can understand all the things about simple moving average. Have a nice day. Bye bye.